All right, I'm sure we'll have a few more folks come in here, but value everyone's time. So let's get started. Well, first off, good morning and welcome. Before we get into the webinar itself, I just wanted to go over a few housekeeping items. First off, thanks for taking the time to attend. I'm Troy Beaver, a partner here at HalenHardy, and will be your presenter for the webinar. Also on here from our client success team is Sarah Noy. Sarah will be managing the chat portion of the webinar. So if you have anything you want to say or questions you want to ask, please go ahead and throw them in there and she will be able to get them organized for the Q&A session. And speaking of questions, we will save the Q&A portion of this for the end of the webinar. However, if a question does pop in your mind, as I mentioned before, just go ahead and throw it in the chat so you don't forget about it for the Q&A session. One other thing I did want to mention, I am trying to keep this webinar as engaging as possible and not really go into heavy detail on regulations around this area. I will hit on them briefly, but this is more just talking about our customers' problems and solutions that were developed to help solve them. If you do have any questions on regulations or regulatory stuff, I'll try to answer them as best as possible. However, I'm not the regulatory expert. We do have Karen Hamill on our team, who is the regulatory expert, and she will be able to answer any of those questions that you might have. If it's not today, we'll definitely follow up with you after the fact and get you the answers that you need on that side of things. And then finally, we are streaming this live on YouTube as well. So if for whatever reason at any time you have any technical difficulties with the webinar, you can access it on the HalenHardy YouTube channel. Just go to YouTube, type in HalenHardy, go to our channel, and click on the HalenHardy May webinar, and you will be able to access it that way. All right, so getting started, before we get into the managing stormwater inside a secondary containment portion of the webinar, I know there are a lot of folks on here who may not know a lot about us at HalenHardy. So I'm going to do just a quick overview on who we are and what it is we do. So at HalenHardy, our mission is to simplify spill and sediment control. What's that mean? We help environmental and operations professionals by developing products specifically engineered for the mobile outdoor workforce. We also ensure that our products occupy minimal space in vehicles, equipment, and facilities due to the fact that most of our clients are working out of pickup trucks, out of mobile vehicles, trailers, those types of things, as well as designing products that deploy in about half the time and are easier to maintain than conventional options out there on the market. So where are our four core areas of focus? We focus in four core areas. First one being spill cleanup and containment in the outdoors. And that's anything from land-based spills in wet, rainy conditions to containing and cleaning up spills on water to products that you can put under pieces of equipment that may persistently leak. Second core area, which we're mainly going to be talking about today, is filtering oily sheen from stormwater inside a secondary containment. Third area is filtering sheen, silt, and sediment from stormwater runoff, and that's anywhere around ditches and outfalls to storm drains, where we've created a line of products to filter out those contaminants that are very easy to maintain. And then finally, just the dewatering area, whether that's pumping out vaults and you need to filter out sheen and sediment, or getting into larger dewatering projects where we have what we call our instant coffer dam. You can see the picture on the right there, which instantly dams up streams to allow you to do pump around applications or dewatering applications. So just a real quick question to at least wake you up, and hopefully I'm not boring you at this point, but if you just want to type in the chat, yes or no, Y or N. How many of you have secondary containment in the outdoors? And if you don't know what secondary containment is, then I'm going to hit on that in the next slide, so don't even worry about answering. But if you do have secondary containment, how many of you have them in the outdoors? I'll give you a couple seconds to kind of get that in. So real quick, what is secondary containment and why is it necessary? At a very basic level, secondary containment is a liquid type barrier that will contain hazardous materials that are released from a storage container. It can be any type of system or control measure that will stop a spill from leaving a particular area. More than a dozen EPA and OSHA regulations require secondary containment, and it is mentioned in several industry standards. The ultimate goal of secondary containment is to help prevent any damage to the environment by providing a predetermined area to go should the primary container fail inside of that secondary containment. Who needs secondary containment? Well, if you store hazardous materials and or hazardous waste in your facility, you are likely need to have secondary containment systems to meet one or more regulations. OSHA and EPA have a very broad definition of what constitutes a hazardous material. You probably already know if you have hazardous materials on site, but basically if it has a safety data sheet or an SDS, or it is a liquid that could harm a person or the environment, chances are pretty good that there's a regulation that considers it to be hazardous. Now, this doesn't obviously mean that every single thing in your facility that has an SDS requires secondary containment, right? I mean, small containers that don't have potential to contaminate the environment would not require this. For example, you wouldn't need secondary containment for the bottle of hand sanitizer on your desk. That sounds pretty silly, right? Even though it would be considered hazardous due to its flammability. If it spills, it could easily be cleaned up and has no potential to enter a floor drain or contaminate the environment. As a rule of thumb, look at liquids that come in drums, totes, bulk tanks, as well as equipment or machinery, and focus your secondary containment efforts on those areas first. Types of secondary containment. There's really no definition of exactly what the secondary containment needs to look like. But essentially, as I mentioned before, the secondary containment is a liquid type barrier that can or that will contain hazardous materials that are released from a storage container. It can come in a variety of configurations and styles. It can range from a simple concrete berm that you see in the top left corner there to a spill pallet in the top center, or even a double wall tank to a complex underground vault system. A simple example of secondary containment would be taking a 5-gallon pail, which would be your primary containment, and putting it inside of a 55-gallon drum, which would be your secondary containment. Another example is placement of a 55-gallon drum or large fuel tank, which would be your primary containment inside of a liquid-tight concrete bunker. The outer wall of a double wall fuel storage tank is also an example of secondary containment. The inner wall is your primary containment. The outer wall would be your secondary containment. Overall, the size and design of a secondary containment unit or device depends on what type and the amount of material that it holds. Again, I'm not going to go into great detail on that. That's more regulatory side of things, but just know that there is regulatory wording that will go into more detail on this type of stuff. So what are the volume capacity requirements of a secondary containment system? The federal containment regulations say it must have sufficient capacity to contain at least 10% of the total volume of the primary containers inside of it, or 100% of the volume of the largest container, whichever is greater. So just to give you a quick example, if you have two 55-gallon drums, so you have a total volume of about 110 gallons, 10% of the total volume would be about, it is 11 gallons. 100% of the largest container stored in there, which is two 55-gallon drums, would be 55 gallons. So 55 gallons is greater than the 11 gallons. So you would need to have a secondary containment for 55 gallons. Now, remember, these are just the federal containment regulations. States and municipalities have to follow at least these volumes, but may even be stricter. A lot of states require 110% of the containment of the largest container. So you'll need to check with your state, local municipality on their secondary containment regulations. But at a federal level, 100% or 10% of the total volume or 100% of the largest container. As just, oh, sorry, missed a portion here that I wanted to talk about, the precipitation. In addition to the capacity requirements, you need to take into account precipitation. It does say that you should put every outdoor containment under roof. Now, we all know that is not practical in pretty much every situation. So it's a good idea to calculate what a 100-year worst case storm would look like and calculate that into your capacity requirements. So obviously, as I just mentioned, you cannot just let the rainwater accumulate inside of your secondary containment, or else it would take up the volume capacity needed to contain a spill from your primary container, right? So what do you do? Most customers that we work with do one of two things. They either manually drain the water or they call in a vac truck every time it rains. So what are the complaints that we've heard over and over again about these methods? First, if you're manually draining, it becomes very time consuming. If you have one or two secondary containment systems, then this might not be a huge problem. However, if you have numerous systems and they're larger, it takes significant time to walk around, open the valves, stand there, watch the water drain, and then close all the valves whenever finished. Not to mention, I don't think there's many companies out there who have someone specifically designated to do this task, right? Most of the time, they need to get to their other daily tasks done, and this just takes time away from that. Second problem, you need to make sure that there's no visible sheen or spilled product inside, or else draining that rainwater into the environment would defeat the purpose of secondary containment, right? However, a lot of times sheen is very difficult to see. I'm sure a lot of you folks have run into that, right? You may have the wrong lighting conditions. It may be darker, time of day that you're doing it, early morning, late at night, or late in the evening. And you may accidentally discharge that sheen directly into the environment. A lot of times, obviously, you're just relying on the human eye to determine if the water has a sheen or not. Human error does happen, obviously, and it can be discharged. Third, we've heard time and time again, valves are open to drain the water, and then the person forgets to close them. Spill then occurs inside of that secondary containment, right, and goes straight out the open valve, again, defeating the purpose of having secondary containment. This goes back to the fact that the task of draining water from containment is not something that people were hired to do. It tends to be secondary or tertiary task, and sometimes folks forget to close the valves. Finally, to be on the safe side, the final complaint that we've heard over from our customers is they'll just call in a vac truck, right? This eliminates the human error associated with discharging sheen water, forgetting to close the valve. However, at hundreds, if not thousands of dollars, this quickly becomes an extremely expensive alternative. We actually had one customer who was spending approximately $20,000 a year per containment to vac and haul the waterway. Whether it had a sheen in it or not, they were just kind of playing it on the safe side. So you can imagine if you have multiple containment units in your vac and hauling, and they're larger containments at $20,000 per containment, that become fairly expensive. We also problems with existing solutions around this area. When asked to help one of our customers address the issues associated with stormwater inside of their secondary containment, they've actually told us, this was a few years ago, we have tried these filter valves or self-bailer devices before, but there were issues with them. not knowing at the time exactly what they were talking about, just knowing that they had a problem with sheen water inside of their secondary containment. We dug in and we found out essentially petroleum filter valve or self bailer are made to attach to the outlet of your secondary containment. They have a various medias inside, depending on who makes them, that acted almost like an simple oil water separator, right? It would filter out the sheen from the rainwater. In the event that a spill happened inside of that secondary containment, some of them would actually automatically shut off, preventing the spill from escaping, at least to a certain extent, right? Most of them still allowed about 6 ounces up to 1.5 gallons out before completely shutting off. So really didn't address the issue associated with what if a spill happens inside. Worked okay on filtering the sheen out of the water. On top of that, we continually heard the following complaints. First, they're big and bulky, so you can see in the first picture, typically between 4 to 9 inches in diameter and 12 to 44 inches long. This makes them tough to attach to outlets that were close to the ground, not to mention created a tripping hazard for workers as they're walking by the containment. Second, a lot of them drain very slowly, anywhere between about 7.5 gallons to 55 gallons per hour at 2 inches of head pressure, which is typically what's inside of a secondary containment, your standard above ground secondary containment, right? If you're getting more than a 2-inch rainstorm, it's very rare that it happens. This meant that larger containment units would take days to drain at those rates. Third, since the containment units are in the outdoors, there was always sediment, debris, algae inside that would prematurely clog the filters, causing it to need to be replaced more frequently. And these things aren't very cheap. So that brings me to the fourth. Since they were replacing them so often, it became extremely expensive, typically ranging between $500 to $2,500 per filter. They became pretty prohibitive for a lot of our customers. So knowing this, listening to all these problems that our customers were telling us, we went to work on developing a solution. After numerous months of testing different designs and methods, we came up with what we call the Drainiac Petroleum Filter Valve. It's an oil water separator that attaches to the valve on your secondary containment, right? It allows stormwater to drain from your secondary containment while effectively filtering out oil or fuel sheen. In the event that a spill would happen inside of your secondary containment and you have the valve open, the polymers on the inside of the canister of the Drainiac will swell up and instantly shut off the valve, preventing a catastrophic oil or fuel spill from escaping your secondary containment. We also developed a pre-filter system that will filter out any sediment, leaves, and debris in order to prevent the Drainiac from prematurely blinding over with sediment and having to be replaced due to the fact that it's clogged. It is extremely compact at only about 3.5-inch diameter by 6 inches long. This allows it to attach to outlet valves that are close to the ground while also not creating a tripping hazard. The various sizes drain anywhere from 56 gallons an hour up to 387 gallons an hour at only 2 inches of head pressure. This is about 7 times faster than any comparable products. Not to mention it saves money by not having to hire expensive vac trucks to pump and haul away mostly water with just a little bit of sheen on it. So how does it work? This video will show you essentially how it keeps up its flow rates while filtering sheen out. So this is the smaller Drainiac you see here, 3.5-inch diameter, 6 inches long. We're using in this video dyed diesel fuel, but it works on the wide range of hydrocarbons. Here you'll see not only does the water drain through quickly, it also is effectively filtering out any of the sheen in that water, preventing it from escaping what would essentially be your secondary containment. And then the second side of it, where I talked about it prevents spills. In the event that a spill does happen in secondary containment and your valve is open, it instantly swells up and shuts off. Again, dyed diesel fuel I'm using, you can see here. And I promise you, there is not a plug in that. It is just the polymers, the Drainiac. But you can see it instantly hits the polymers and swells up and shuts off. So no fuel escaped. So as I mentioned before, that's how it works. One of the major complaints with any of the pre-filter systems or lack thereof that go along with the other petroleum filter valves on the market is the fact that in outdoor secondary containment, they get very dirty, right? Anything from dirt to leaves to algae, pollen, or even just garbage ends up inside of these secondary containments. Every time it rains, this crap heads towards the drain, right? Even without a filter valve on the outlet, it tends to be a hassle and clog up the outlet itself. When talking with our customers who had tried other filter valves in the past, one of the things that we discovered was that they were frustrated with how often they needed to change out the filter valves due to it clogging with the various things. So we developed a pre-filter system to help extend the life of the more expensive Drainiac, right? It's a two-part system. First, you have your silt trap socks, which you can see in the picture on the left, as well as the top right picture. These are made to capture the large debris and sediment and keep it from getting to the outlet. Second, the pre-filter sheets, which you can see in the bottom right picture, as well as the arrow pointing to the center of the left picture. These sit directly over the outlet of the secondary containment and filter out any of the finer sediment that may get past the socks. Not to mention, it can also filter out oils and fuels, which will also extend the life of the Drainiac, right? As the Drainiac filters out more sheen, the polymers inside continue to swell up, eventually reaching its saturation point so no sheen escapes. With the pre-filter sheets, they're actually our filtration husky material, which is made to filter out oils as well. So it's going to capture a lot of that and prevent your Drainiac from prematurely swelling up and shutting off. We're seeing the pre-filter components extend the life of the system upwards of 6 to 9 times. Plus, the pre-filter components are much cheaper to replace and can even be cleaned off and laid back down. We also have a pre-filter system if you have an internal sump on your secondary containment system. In that case, you would obviously be mounting the Drainiac inside of the sump, which is inside of your secondary containment, like the picture in the top left. In that case, obviously, you're on the inlet side as opposed to the outlet side of secondary containment. So in this case, we would need something to go over the Drainiac to filter it. So we created a pre-filter sleeve that just slides over top of the Drainiac and filters out any of the silt, sediment, debris, as well as I mentioned before, any of the oils or fuels. You can see this in the bottom left picture. It is it is made from, again, our super thick husky fibers, which have the ability to allow water to pass through while filtering out bulk oils and fuels. It also filters sediment down to 53 microns. So if you look at the picture on the right, and I know Mark is on here, so at the end, he may have a little bit to add to this, but this is a good case study. We were approached a few years back by one of our electric utility clients who had an internal sump at a substation like the picture on the left. Due to the sediment clogging the filter valves, as you can see by the picture on the right, he was replacing them every 2 to 3 months at about $2,500 each. We developed the Drainiac and pre-filter system specifically for this application. Didn't need to replace the Drainiac for about 18 months. So went from replacing them every 2 to 3 months to 18 months. saved him around, and he can correct me if I'm wrong, but if I got the numbers right, about $13,000 in just product alone, not to mention the time that it took to travel to the remote substations and change them out every 2 to 3 months. As far as the compact nature, Drainiac is obviously also super compact, which I mentioned before. We have two sizes of Drainiacs. The small Drainiac is the one that you see on the right here in the picture. It's 3.5-inch diameter by 6 inches long. We also have a larger Drainiac, not shown in the picture here, but it's a 6-inch diameter by 8 inches long. You can see in this picture, though, that's a comparable product that drains about 7 times slower than the Drainiac. And costs about twice as much, but is about 400% larger. As I briefly mentioned before, the compact nature of the Drainiac allows it to be attached in tighter spaces and connect to outlets that are closer to the ground. It also allows it to be installed in more of a vertical position, which will give it more drop or head pressure and allow it to drain faster. And I'll show you a couple pictures here in a second of what that looks like. Speaking of draining faster, one of the other benefits of the Drainiac is that it's set up to drain faster. Due to the unique design of the internal filtering system, it can still capture the sheen while allowing water to drain up to 7 times faster than comparable products. The one complaint that we heard over and over again from our clients was that it would take upwards of 15 to 20 hours to drain even a small 10-foot by 10-foot containment with just a couple inches of water in it. When using other filter valves, we wanted something that would only take an hour or two. So the small Drainiac is set up to drain at 56 gallons per hour at 2 inches of head pressure, while our larger Drainiac is set to drain at about 387 gallons per hour at 2 inches of head pressure. The reason I say 2 inches of head pressure, we only test ours for drain rates from 1 to 0 inches and then 2 to 1 inches of head pressure, which simulates your real world scenarios, right? Never are you going to allow your containment to fill up with 12 inches of rainwater, or else there's no capacity left in there if a spill would happen. So obviously your typical rain event isn't more than an inch or two. So if for whatever reason you do have a scenario where you may have more head pressure, just know that they will drain at even faster rates than those that are stated here. This is just showing you the 2 inch to 1 inch drain rates. It's also laboratory tested. The Drainiac's been tested by an independent laboratory using EPA method 1664A for oil and grease concentrations in water. All samples came back at non-detect levels, testing at various different concentrations, and we have that in a form that we can send out if anyone wants to see it, but essentially non-detect at all various concentrations of oil in water. Speaking of some of the installations, here are just a few of the installation methods. Where I was talking about getting more of a vertical drop, you can see the picture on the left, installing a 90-degree elbow and getting that full vertical due to the compact nature of it just adds more drop or head pressure to allow it to drain faster. Obviously, as you can see in the second picture, sometimes the outlet drain is right up against the ground or an inch or two off. And it's on concrete. So, there's no digging down. So you're going to be at those minimum flow rates that I showed you before. But, if you have the full drop, you're going to add to the flow rates that I was showing you before because you're obviously creating more head pressure. The standard size Drainiac comes with a 2-inch male fitting on it. We also do a 1-inch fitting for skid mount containment units, even went down to a 3/4-inch fitting for some of our smaller applications. Can also be adapted to a 4-inch outlet by using a Fernco fitting, and can also create a manifold to increase flow rates and capacity should you need to. So you can see that in the picture on the far right. And that's typically due to size of containment. You may want it to drain a little bit faster because you have an extra large containment in one unit won't be able to do it. So you're going to want to manifold them and add a couple additional units. The next installation method that we've developed, aside from your traditional gravity feed method, is our self-pumping baler system. This was brought upon due to one of our customers who had a containment with an internal sump on it. So you can see the picture on the left there is their internal sump inside of the containment. However, there's no drain attached to the containment itself or inside of the sump. So every time they got an inch of rain, they would call an environmental contractor in to pump out the containment. They were averaging about $500 per pump out, plus about 40 cents per gallon to transport and treat the water. They're averaging around 40 pump outs per year at a total cost of around $25,000 per containment. Talking through it with the customer, we developed a self-pumping baler system that helped to significantly reduce their annual spend. You can see the picture on the left shows the sump inside the containment. The pump turns on when the water hits a certain level and shuts off at about 4 inches from the floor of the sump. The middle picture shows you the complete system from the inside of the containment, and the right picture shows you the system from the outside of the containment. Water is pumped up from the sump through the black box, which contains the pre-filter system, and then discharges through the Drainiac for final treatment, which you can see there on the right picture. The white hose there on the right picture is the overflow and directs any overflow back into the containment. The whole system's solar powered. There's also a stock tank de-icer, which is the red thing that you see there on the left, in the left picture, which makes sure that the water doesn't freeze in the sump. Overall, system paid for itself within the first year and has been a significant cost savings moving forward for this customer. So much so that they went from 1 unit to 5 units this year. And then the final area that I'm going to touch on, and then we can jump into any Q&A, is the portable secondary containment systems and filtering stormwater from those. Some of you might know portable secondary containments as something like a berm or a flexible containment. You can see the picture here on the slide. These are portable, hence the name, and typically are made from some sort of flexible material that have sidewalls that can fold up and down. They're also great for storing various containers or equipment in because you can easily get in and out of them by driving over or folding down the sidewalls. But they also have the same issues with stormwater accumulating inside of them. So what's the major problems associated with stormwater inside a portable secondary containment? The first major problem is they typically don't have drains, which means they need to be pumped out or manually drained by dropping the sidewalls. If you're dropping the sidewall down to manually drain it, then there is the issue that if a spill occurs while in there and you have the sidewall drop, then it's just going to go rushing out onto the ground and into the environment, again, defeating the purpose of secondary containment. If there is a drain, it's usually just a bulkhead fitting that's installed in the sidewall. The problem with a bulkhead fitting is that it cannot be installed flush with the bottom of the containment and typically leaves about 2 inches of water in there at all times. So you can see that in the picture on the right. This 2 inches of water takes up much needed spill capacity of the berm, while also creating an issue with just always having stagnant water inside there, as well as water freezing inside in the winter months. This is actually the exact scenario that our customer presented us with a couple years ago. They were storing a large mobile transformer inside a portable secondary containment. The water could not drain fully out because they had a bulkhead fitting, so they had about 2-3 inches of water. It happened to be in the winter. Everything froze. It completely froze the mobile transformer inside of the secondary containment. So you can imagine the headache that they were having with that. So in order to prevent this from happening, they came to us to help them develop a solution. The question was, could we come up with a way to drain the water all the way to the floor while also effectively filtering the sheen from inside of the portable secondary containment? The solution that we developed is what we like to call the snoutlet. It's the outlet drain for our HARDYBERM portable secondary containment. So you can see on the left, this is what it looks like on the interior of containment. The opening goes all the way to the floor, which allows water to drain completely from the containment. The picture on the right shows you the exterior of the containment drain. Comes off like a snout, hence the name snoutlet, and you could connect the Drainiac to the end of this. The snout allows you to get additional fall from wherever the level of the containment is, which creates more head pressure, allows it to drain faster. Depending on the size of the containment, there could be 1, 2, or 4 of these snoutlets on the containment. Smaller units will have 1 because it'll be easy to turn them and make sure that the snoutlet's always on the low sloping side of the containment. Medium-sized containments typically have 2, which means they only have to be turned 90 degrees to have them facing to the low sloping side. Plus, you can attach 2 Drainiacs, which will allow it to drain faster. And then your large units typically will have 4 units, 4 snoutlets in each corner, which means you don't have to turn them at all because they are large. Once you open them, you'll always have at least 1 snoutlet on the downhill side, which will allow you to drain all the water out of your secondary containment. So the complete system, going back to sediment, prematurely clogging, we also wanted to make sure we were addressing this. Very similar to the above ground permanent containments that I was showing you before. You can see what it looks like here. We have the pre-filter system, your pre-filter sheet that goes over the outlet on the interior of the berm, your silt trap socks that are used to weigh it down as well as filter out any of the bulk, sediment as well as debris. And then the only difference here is, I don't know if you can see them, but there's black clips that just hold it to the top of the secondary containment. Since this is a flexible material and not concrete or something more solid, we just added the clips in to make sure that it stays in place. So back to our customer and their problem, we went from concept to design to production in a little over 2 months. The first unit was delivered to our customer 3 months after the initial discussion. And as you can see in the picture, they were put to use pretty quickly. That brings up one final point that I'd like to make before we get into the Q&A here. If you get anything out of this webinar, it's that we have a team of individuals who like to problem solve by creating products that make our customers' lives easier. If we don't have a solution, we'll definitely go to work on it. We were just a few ways that we listen to our customers we're struggling with when it comes to stormwater inside a secondary containment, and we came up with solutions to help them. Obviously, you saw the other areas that we deal with on one of the first slides. We're always developing solutions in those areas as well, but this was just meant to hit on stormwater inside of your secondary containment structures. So since I value everyone's time and I don't like to bore people, we got 20 minutes here for the Q&A. Typically doesn't go more than a few minutes, but if you want to, Sarah, if there's anything in there, I do know maybe before we hop in to the Q&A, Mark, I'm not going to put you on the, well, I'm putting you on the spot, Mark. If you'd like to say anything about how we helped you with the Drainiacs, I think we're allowed to unmute you now and let you talk.
Yeah, can you hear me?
Gotcha.
Yeah, it was very interesting and very knowledgeable how HalenHardy actually came on site. We developed a solution, and HalenHardy seen it all the way through to production, and now that's basically the Drainiac valve that I've been using for about 3 years,
Yep.
roughly.
Sounds about right. I think April or May this
Yep.
month was 3 years. So.
Yep, I'm very satisfied with them, and I'm sending the first 2 back that your father wants to take a look at.
Yep. So, yeah, and that's the other thing. I mean, we like to, once things do reach their their life capacity, especially with the Drainiacs. Take a look at, even if we are extending the life for our customers, just take a quick look at, okay, what's happening on the interior of these things? Is there a way to always constantly improve? So, yeah, thanks, Mark, for jumping on and saying some nice things. There's not too many people that like to say nice things about us, but no.
Oh, I enjoy working with you.
No, thanks. Sarah, do we have, I'm not seeing the chat right now, so do we have any other questions that popped up while we were going?
Yeah, we have somebody who's asking if you can say a little bit more about the ice prevention device.
Yeah, it's just a stock. So it's a stock tank de-icer. It's just a common product that's out there on the market. If you got feedstock tanks that or stock tanks that you're trying to make sure don't freeze in the winter, that's how it's developed, or that's what it is. We just took it and modified it to our self-pumping system there. So it attaches into all the mechanicals there, the electronics, and but just there's nothing more than something that we bought right off the shelf to add to our current self-bailing system.
I don't see any more questions here. I don't know if you want to give it a couple minutes or. Okay, we have a question. Have we looked into options for anchoring or attaching the pre-filter sheets for the taller containments? It seems like a waste just to have longer pieces to drape over.
Yeah, so depending on what type of material the containment is, if it's some sort of steel or poly material, we can actually attach just like a double-sided Velcro, adhesive Velcro, if that would be the issue that you're looking for. Obviously, if it's more concrete, and you're talking about large concrete walls, that stuff's not going to stick as well, but it's something we haven't run into that issue as much. I mean, I think the standard size that we run into is about a 10 to 12 inch high wall. So yeah, there is a little bit of wasted material obviously going up and over that wall, but the nice thing about it is when that bottom portion becomes saturated or filled with sediment, then you can easily just flip them over and use the other side. So, you're still using up a lot of the material itself. And then obviously the more it can run out into the secondary containment floor itself, the better, because it's stopping the sediment at an earlier stage and keeping it as far as possible away from the actual outlet itself.
So same person for that most recent question, Troy said a lot of their walls are 2.5 to 3 feet high.
Okay. Yeah, no, I'd be interested in taking a look and seeing if we can come up with a way to attach it and just use our standard size. The standard size is a 16-inch width by, I believe it's 20 inch length off the top of my head, maybe 24 inch, but I think it's a 16-inch width by 20-inch length is a standard sheet. So if there is a way for us to figure out to attach it to concrete, we'll be happy to take a look at that, no doubt.
This person said, can we have contact data and will you do a presentation for specific facility with a need for your services?
Yeah. Yep. So here's contact info. Feel free to call or text or email me. At the top there, it's my cell, any hour, and email. As far as, most of my stuff, this is the first year I've really gotten into webinars and doing big webinars. Most of my presentations are either facility or company specific. So happy to come take a look at facilities, talk with the folks there, hear the problems that they're dealing with, and see if we can help out.
That's all I have for questions so far.
All right. Well, if there's no more questions, you get 14 minutes of your day back. So relax or do something productive, whichever one you want to do. But thank you. No, seriously, thank you for being on. We really appreciate it. Team here at HalenHardy, as I mentioned, is here to help you guys. So if there's anything you need at all, any questions, here's the contact info, both Sarah and myself. Feel free to reach out, call the office, which is on our website, HalenHardy.com. You know, any way to reach us, any questions you have, we're here to help. So thanks again. Appreciate everyone being on, and have a great rest of your day.
See ya.